Hello everybody, welcome back to the channel. My name is Dave and today I'm going to be doing some work on my 1990 model Club Car D golf cart, and this is the second video in the series. So if you've missed the first one, there should be a link above here somewhere, or if it's not there, then I'll put a link down in the video description for you to watch. So this is a 36 volt golf cart. I bought it on Facebook Marketplace for $2,800, and the seller, when I bought it, assured me that the batteries were good and that it was a working cart. But when I got it home, one of the first things I realised is that that wasn't really the correct information. I had tried for many weeks to charge and discharge the batteries, and I just couldn't get them to hold a charge. And in the first video we went for a bit of a drive down our driveway and really only got about 300 metres and the batteries were flat. So I had to make the decision to replace the batteries, and I really didn't want to just put a lead acid battery back in it. I wanted to put a lithium ion battery in, and also want to put a solar panel on the roof up here, so when we're using the cart outside working on the farm, that it will self-charge itself. So that's the plan. So I went and hunted around on eBay and I found some 12 volt lithium ion batteries, and they turned up at the end of the first video. So today's exercise, being a rainy day in the workshop, is to continue that process and to get the lead acid batteries out and to get the new lithium ion batteries in. So let's get started. Okay, the first thing I'm going to do is just take a couple of photographs. I've just got my phone here. I'm going to take some photographs of the setup as it is now using the lead acid batteries, just in case at some stage I have to go back and put them back in or do something. At least I've got a record of where the wires are going. What else? Maybe down here a little bit closer of those ones there. Yep. And now we'll start on taking all of these connections off and taking out these lead acid batteries. Well, the batteries are pretty heavy. I was just going to pull them straight out, and then I noticed very nicely written on the top here, it says do not lift by the cap. So what I'll do is I'll put a strap through these eyelets, and then I can hopefully lift them up a bit. I can get it through there. Yep. Be interesting when we get these out to weigh how much they are, because I think they're going to be pretty heavy, and there's 6 of them, so it's going to be a pretty big weight difference, I think. Right, if I do that and then maybe you try and hold all that together. I should be able to lift them out. Oh God. Ugh. Man, that was heavy enough. Right, try this one down here. So these batteries, in the first video I mentioned that I thought they were from 2008, but on further research it appears that they're from 2018. So currently this is 2022, so they are 4 years old. I would think they would probably be on their last legs anyway if they were properly maintained, but they just won't hold a charge. Since I've shot the first video, I've actually had the batteries on the charge and discharging them and charging them and driving around a little bit, and they haven't got any better. You can charge them up to almost their full voltage, but they don't have the amperage, they don't have the capacity, they just go flat straight away. Right, let's try this one. Oh, they're heavy. Oh. Oh. Hello, last one. .4. 10.1, 10.1. Why is one of them 10.3? Huh. This one's 200 grams heavier for some reason. Right, let's put one of these big ones on and see how much one of these ones weigh. Oh, okay, I can do it. I can do it. 28.1 kilos. Whew. We've taken out the 6-volt lead acid batteries, and the total weight of those batteries was 169.8 kilos. And we're putting in 3 of these 12-volt lithium ion batteries, and the total weight of those is 30.3 kilos. So by taking these ones out, we're actually saving 139.5 kilos, which is what, the equivalent of 2 people that we're not going to have to lug around in our electric farm vehicle. Okay, just to touch on a couple of things that I was talking about in the first video, in case you haven't seen the first video, is why I actually picked this particular battery. So the first thing was the capacity, 100 amp hour battery. From what I could find on the internet and other YouTube channels, it looked like the 100 amp hour battery was the capacity that is ideal for an electric cart. The other thing to check for is, can you use all of those 100 amps? There are some batteries that had that capacity, but you can only draw maybe 50 amps out at any one time. And if you exceeded that, the BMS would cut off the supply and the cart wouldn't go. So with the BMS, or the battery management system on this battery, you can draw up to the maximum 100 amps at any one time. The second reason we picked this battery was that the battery management system, the BMS in it, allows you to connect these particular batteries in series and I think it's 3 you can connect in series, which is what we want to do for this application. We want to put 3 of them together to give us the 36 volts. And although you combine them and you get the 36 volts, the capacity of the battery stays the same. When it's in series, you get 100 ampere hour capacity, although you've got 36 volts. And the fourth reason, what am I up to? Fourth reason that I chose this particular battery was that the dimensions of the length and the height and the width of it were exactly the same as the batteries that I had just taken out. So these ones will fit exactly in the battery tray where the old original batteries were. So the 2 batteries in the middle fit in there quite nicely. They fit in the channel. And I was going to put this one here crossways, but I'm sort of trying to think out how I'm going to link these terminals up to connect them in series. And ideally, well, these connections aren't really long enough to go to my positive terminal. I could spin the battery around and do that, and they would connect. But then I would have to connect all the way from this terminal here, from the negative, all the way across here to the positive. So the straps I have aren't long enough. So I think what I'm going to have to do is take this battery out and put a floor in this side. So when I put the battery in, I could actually put it in the same direction as those ones. So I think what I need to do is go and find a bit of timber or something and put a floor in there. This timber is just some offcuts of some what we call in Australia yellow tongue flooring. It's just a 18mm particle board. It's already been sealed, but once it's cut I'll give it another coat of paint just to seal the edges and make it a bit more robust to put on the floor. So I've done one. I've just got to cut this one down. Just got to measure this, make sure it's the right width. So size of the floor is 255 by 375. 375. I mean, nobody's going to see it, so it doesn't have to be exact, but that's good enough, I think. Oh. I was just going to put a floor in that side, but then I decided to do the same floor across the bottom, so all the batteries are going to sit level when they're all connected. I thought that might make it a little bit better. So I've put a floor in 3 sides. This particular bay in here won't actually have a battery because there's 2 that are here and 1 that's over here. This side I've got a piece of timber that I've put in here, and I think what I'm going to do is I'm going to mount my solar battery charger controller on here when we get to that stage. I'm going to reuse some of my cables used to link across. That one is going to be a little bit long there, but I can put a bend in it, and this is the other one which has to go across here, and that's about the right sort of distance. So I think that'll look quite neat. I haven't got all the one colour unfortunately, so for this stage I'm just going to have to go with a red one and a black one. I was going to make up some angle to hold the batteries down, but then I found some cheap battery straps at the local fishing store. So these are a nylon strap with a buckle on them, and they have these things that will bolt onto my wooden floor, and I think that's probably the quickest, cheapest way of holding the batteries in. Right, well I've just finished connecting up my batteries together, so I've put on these connecting straps here and here. So now they're connected. I've actually got 36 volts combined from these 12 volt batteries. So from the positive outside on this battery, I've connected the negative output to the positive of this battery, the negative of this battery to the positive of this battery, and then this is the output for the earth side. So they're all right to go. The next thing I want to do is, I've got a bit of a hole in this area down here where the floor and this stays, and what I'm going to do is I'm going to mount my boost controller for the solar panel charger. So this is what I've got. It's a RENOGY Rover Boost 10 amp solar charge controller, and this was probably the only of a few ones that I've found online that will actually boost the 12 volts up from a single solar panel up to 36 and 48 volts to actually charge a battery system like I have. So that's a RENOGY system. I've also got to put in a ANL fuse. So this is a 20 amp ANL fuse that'll go in the positive side. I've got some battery connection cables, and that came with the boost controller. They're 2 cables and they're black. It'd be nice if one of them was red and one of them was black, but I'll just put a bit of tape on the ends there to identify which is positive, which is negative. I've also got this shunt controller here, and this goes on the negative side, connects to the negative pole of the battery, and it's got this multi-pin connector here on the top, and what that does is it connects into this little cable that's down here, and that feeds into a battery monitor. So over on this side, I've actually got a RENOGY battery monitor, and these I had a look at some reviews online and some videos, and they seem to be very good. It gives you quite an accurate display of what your battery capacity is and the number of amps that you're drawing. And that fitted really nicely into the dash of my club car cart. There was something in there before, it looked like an ashtray or something, but when I took that out, this panel actually fitted in there really well. So that's all in there and ready to go. So I've just got to hook it all up. So that's this afternoon's exercise, is to fill up this area here and connect it up, and then we'll go on to the next step. Righto, that's pretty well installed now. So I've got my fuse block here. This side goes to the positive of the first battery. 20 amp A&L fuse here, and the output side goes up to my RENOGY boost controller. On this side we've got the shunt, which is connected to the negative side, so the larger cable goes back to the negative on the battery. This side here goes to the negative of the boost controller. There's a little multi-pin connector here that goes across to the battery monitor, and this small positive cable feeds in, and that just provides power for the battery monitor. Those two outputs here come up to the boost controller that go in here. I've got my lights on here. The blue light indicates that it's a 36 volt lithium battery system. I haven't got the panels connected yet, that'll be the next job to do, but at least it should be powered up now. The system should work, and I should be able to see something on my battery monitor. I've connected my RENOGY battery monitor up to the shunt, and as soon as you connect it you get a display here, and what it's actually showing me already is I've set some of the things up already in it. So I've changed it from the default of 0% battery capacity here to 100% just by holding this top arrow down for a couple of seconds. It defaults that to 100%, and I know the batteries are charged, so that's an accurate figure. The other display it shows me on the side is the capacity in amp hours left in the batteries, and it's showing 100, so the batteries are fully charged. Let's look at what else is here. So the capacity of the system is currently 39.9 volts. We're drawing 0.01 of an amp and 0.4743 watts. So really this is just the draw on the system from the monitor actually running. There's no actual greater capacity than that because the cart's not moving at the minute. The middle display here gives you time remaining, so when you're actually moving and you're drawing a lot more current, this display will give you how long you have left as an estimate based on the capacity of the battery and the level in volts of the battery. So to set it up, what we have to do is just go to hold the OK button down, and it'll go to a page display here. And I have to say first off that it's sometimes a bit difficult to see, but there is a little cursor that runs down the side of this display, and sometimes you have to look in from the angle to actually see which line the cursor's on. So here you can set up different parameters. So I've just left this as 0 in the defaults at the minute for the 0 voltage and the power off function. The alarm that I've actually set here is to go off at 50 amp hour. So if you draw the capacity down from 100 and it falls down to 50, then an alarm will go off to tell you that you're running down on low power. You can come up to the next page, so you can tell this that the capacity of the battery system is 100 amp hour. The voltage is 36 volts, and again the 0 and the power off I've left. I think that's all that's on there. Just go down to see what else is there. No, that's all good. And then top button goes back to the default display. So that's all connected, seems to be working okay. Let's take it for a drive. Well, I can tell straight away that there's a lot more power in the system. It's got a lot more get up and go, which is good. The speed is the same. It doesn't go any faster, but certainly it's going to have a lot more range. But as I'm driving along, I can actually look at the battery monitor here, and I can actually see that the battery voltage and the capacity I can see changing a little bit, but I can't see anything on the display for the draw or the amps being used in the system. So I think there must be something wrong in the wiring, and I actually think I know what it is. I think what I've done is, when I've wired this shunt in here, that I've actually missed one of the steps. So the battery terminal up here on the negative side, this is the cable that actually runs to the electric motor. And I think what this is doing, this should actually be connected to the output side of this shunt, so the current is actually drawing through, and it can be measured by the battery meter. The other wire on here, this white one, I think is for the key operation, so I might leave that there and just reposition this one. And the other thing I want to do is, as I had a battery charger turn up, a lithium battery charger, and it's got an Anderson plug on one end, and on the other end it's got a couple of terminals. So I think what I'll do is, while I've got this apart, is I'll actually connect this up here. So I've got this lead sitting down the bottom here if I need to connect my lithium charger that runs off 240 volts. I've just finished doing those few modifications to the position of where the earth is now on the shunt, and I'm back looking at my battery monitor. I've got the back of the car up on car stands at the minute, so the wheels are off the ground, and I'm just going to now hit the accelerator pedal and see what's on our display. So here we go. So I can see now that it's telling me that I've got a draw of about 21 amps on the system and currently about 800 watts. So that's good that I know now exactly how much the system is going to draw out of the batteries. The middle line there is telling me that at this current speed or draw that I've got a capacity of 4 hours and 55 minutes runtime. I think that's pretty optimistic, but at least now I've got a guide on how much I'm drawing on the motor and how much I've got left in the battery system. Well, I've got to say, I'm more than happy with the conversion to the lithium batteries. Performance is good, and I'm sure it's going to give me a lot of range to run around the farm for at least a couple of days, maybe even a week. I had to go out and buy a 36 volt lithium battery charger to run off the mains because RENOGY yet to supply my 12 volt solar panel that I purchased. So that'll have to wait to be in the next video. But anyway, for the time being, I hope you enjoyed the conversion process. Hope there was enough detail in there if you want to do the same thing. I appreciate everybody watching the videos. All your comments are welcome, and we'll see you in the next one.